Hi, dear students and friends. Today in this lecture we are going to study Hermite's interpolation formula. Also to discuss how to find Hermite's interpolating polynomial for a given data. First we consider a function y is equal to f of x, which takes the values f of xi and f dash of xi. And here I goes from I is equal to 0 to I is equal to n. Means there are n plus 1 points corresponding to the values of xi. Also I goes from I is equal to 0 to n. Means there is a function y is equal to f of x which takes the values of f of xi and f dash of xi, where I goes from 0 to n corresponding to the values of x from I is equal to 0 to n. Then by using Hermite's interpolation formula, the Hermite's interpolating polynomial for a given data is given by equation f of x is equal to summation from I is equal to 0 to n of aix into f of xi plus summation I is equal to 0 to n of bix into f dash of xi. And here on the right hand side aix, and that aix is defined as aix is equal to in bracket 1 minus 2 into x minus xi into li dash of xi into lix bracket square, and Bix is defined as Bix is equal to x minus xi into Lix bracket square. And here in both Aix and Bix there is a term Lix, and this Lix is defined as Lix is equal to x minus xi into x minus x naught into x minus x1 and so on, x minus xi minus 1 into x minus xi plus 1 into and so on x minus xn, and denominator is xi minus x naught into xi minus x1 into and so on xi minus 1 into xi minus xi plus 1 and so on xi minus xn. Numerator is to subtract all the values of x from x except xi, and denominator you take same numerator as a denominator, only changing or replacing x by xi in every factor. Okay, then if you see the formula, in the formula this pix is p of x is equal to summation I goes from 0 to n aix into f of xi. You can find aix by using this formula, and f of xi means values of f of x at x is equal to xi. Means suppose there are four values, means x0, x1, x2, x3, then you can take here f of x0, f of x1, f of x2, f of x3, and in the second term plus summation I goes from 0 to n, and here bix into f dash of xi, and this bix is defined by this formula. Bix is equal to x minus xi into lix bracket square, and then second term is the f dash of xi, means this f dash of xi also will be given in the given data. In short, using this interpolation formula to find out the interpolating polynomial which satisfy f of x as well as f dash of x. This is the advancement of the Lagrange's interpolating polynomial, because this polynomial satisfy f of x as well it's a first order derivative. Okay, then to find out the interpolating polynomial means find out the right hand side. For the right hand side we need to find out aix and bix, and this f of xi and f dash of xi will be given in the data. For aix and bix, first we need to calculate lix. Lix means very simple. Here we can take I is equal to 0 to n. If it is I is equal to 0, then what will happen? L naught of x is equal to. Here we can take or subtract all the values of x from x variable except x naught. Means we skip the first factor x minus x naught and we write x minus x1, x minus x2 and so on x minus xn. In the denominator also here you can take as x naught minus x1, x naught minus x2 and so on. Similarly, we can find L1x. L1 means I is equal to 1. If we take I is equal to 1 means L1x, in the numerator we skip the factor x minus x1 and we take x minus x0, x minus x2 and so on up to x minus xn. And in the denominator we take the same factor, only change x by x1. Okay, in this way we can find L0x, L1x, L2x and so on Lnx. Also for AIX and BIX there is a one more term Li dash of xi. Here if you consider the AIX is equal to 1 minus 2 into x minus xi, this xi will be given in the data, but Li dash of xi is derived by using the Lix. Simply differentiate Lix with respect to x and we get Li dash, and then you can replace x by xi and then we can find out the values of Li dash of xi. Okay, this is the way or this is the formula for Hermite's interpolation formula, and this is also known as Hermite's interpolation formula of degree 2n plus 1. Okay, here important thing is that you must know what is the formula for Lix, AIX and BIX. If you know this formula, then you can take this is the standard Hermite's interpolation formula, and using that formula we can find out the polynomial, and in that case the degree of the polynomial will be 2n plus 1. N means how many number of observations are given in the given data. Okay, now we go for the examples. This is the example number 1. From the following table gives the values of f of x and f dash of x. Obtain f of minus 0.5 and f of 0.5. Means the following table gives the values of f of x and f dash of x. Then to determine the value of f of x at x equal to minus 0.5 and at x equal to 0.5. Hence, we first find out the value of f of x. That's why we have three sub-questions. First question is find out f of x, then find out f dash of x, and then using f of x you can find f of minus 0.5 and f of 0.5. Okay, here table is given. In the table, the first row is given for values of x. This table, first row gives the values of x, second row gives the values of f of xi, and third row gives values of f dash of xi. Here I am taking x, you take xi anyway. Here in the first row x is given minus 1, 0, 1. For the value of x we define first value is x naught is equal to minus 1. For the second value x1 is equal to we write as a 0. Third value x2 is equal to 1, hence we write x2 is equal to 1. Then by observation we can write the value of n is equal to 2. Because total 3 points are given, hence value of n is equal to 2. Hence the degree of the polynomial will be 2n plus 1, means 2 into 2 plus 1 is equal to 5. Means if you find out the polynomial, the degree of the polynomial will be 5. Then to find out the first f of x and then find out the f dash of x by using the differentiation. Okay, we consider the first f of x means find out the interpolating polynomial using Hermite's interpolation formula. In the given problem, it is not mentioned use Hermite interpolation formula, but by the third row we can identify use Hermite interpolation formula and find out the polynomial which satisfy f of x as well as f dash of x. Okay, using the standard formula we can write the Hermite interpolating polynomial for a given data is represented by the equation number 1. What is p5 of x? You write anyway p of x or p phi of x, I am writing this 5 because the degree of the polynomial is 5, is equal to summation goes from I is equal to 0 to 2 into aix into f of xi plus summation I goes from 0 to 2 because n is equal to 2 into bix into f dash of xi. From the second row, we can find f of x0, f of x1, f of x2. From the third row, we can find f dash of x0, f dash of x1, f dash of x2. Hence, we can easily find out the value of f of xi and f dash of xi from the given table. Only part is the to determine the values of aix and to find out the values of bix. We know the formula for aix. As per the above formula, we can write aix is equal to 1 minus 2 li dash of xi into x minus xi into lix bracket square. And second formula, bix is equal to x minus xi into lix bracket square. Okay, then here our I goes from 0 to 2 to find out aix means how many values for a, I is equal to 0, I is equal to 1, I is equal to 2 because n is equal to 2. Hence using aix we can find a0x, a1x and a2x. And then by putting I is equal to 0, 1, 2 in this formula, and we can get the value of first a0x is equal to right hand side, this is the a1x is equal to this right hand side, and this a2x is equal to right hand side. Simply putting I is equal to 0, 1, 2 respectively. Similarly, here in this case bix, I goes from 0 to 2. Hence using bix we can find b0, b1, b2. By putting I is equal to 0, 1 and 2, we get b0 x is equal to x minus x0 into l0 x bracket square. b1 x is equal to x minus x1 into l1 x bracket square. And b2 x is equal to x minus x2 into l2 x bracket square. Okay, then to find out ai and bi means find out a1, a2, a3 and b1, b2, b3. Then you check which values are essential for calculation of a0, a1, a2 and b0, b1, b2 by considering the right hand side of that equation. Here in the a0x, here we need l0x, l1x, l2x. Also in case of b0, l0x, l1x, l2x is required. Okay, also x0, x1, x2 we can take using the table. Also in a0, a1, a2, if you see the first bracket, 1 minus 2 times l0 dash of x0. This term also required to find out l0 dash of x0, then to find out l1 dash of x1 and then find out the l2 dash of x2. And how to find out this value? By considering the value of l0 x, differentiate l0 x with respect to x, we get l0 dash of x and then replace x by x0. Similarly for l1 dash of x1, we consider l1 x and then again differentiate l1 x to get l1 dash and then replace x by x1 and we get l1 dash of x1. Similarly, to find out this L2 dash of x2 by differentiating L2x with respect to x to get L2 dash and again replace x by x2 and to determine L2 dash of x2. Okay, hence for this calculation, first to find out the value of Lix and Li dash of xi and we take I is equal to 0, 1, 2 means find out L0, L1, L2. Then L0 dash, L1 dash, L2 dash. Then we consider next step, we write L0 dash is equal to L0 dash, L0 x is equal to x minus x1. We know as per the formula. L0 x, what is the Lix? Lix means subtract all the values of x from variable x except xi. Here L0 x means we subtract all the values of x from variable x except x0. What is x0? Here in the table we have given this x naught is equal to minus 1. X1 is 0 and then x2 is 1. Hence we can write L naught x is equal to x minus x naught into x minus 1. X minus 0 into x minus 1. Then denominator is we take the same two factors in the denominator, only changing x by minus 1. Hence we write minus 1 0 into minus 1 minus 1. Means we get the term, this is L naught x equal to x minus 0 into x minus 1 divided by minus 1 minus 0 into minus 1 minus 1. And then we simplify numerator and denominator. After the simplification we get L naught x is equal to 1 divided by 2 into x minus 1. Okay, this is the polynomial in x. Also at the same time in a naught we want to find out L naught dash of x naught. Hence we differentiate the same term. We differentiate this L naught x. Differentiation means here we can multiply x inside the bracket. Here is the x into x square minus 1. X square minus x, we take the derivative of x square is the 2x minus derivative of x is the 1. Hence we get 2x minus 1. And then we substitute this x is equal to x naught and x naught is equal to minus 1 and simplify, and we get as a L naught dash of x naught is equal to minus 3 by 2. You can use the calculator for the calculation or for evaluation of L naught dash of x naught. Okay. Similarly, to find out next L1x. L1x means subtract all the values of x from variable x except x1. What is x1? X1 is the 0. What is the remaining value is minus 1, 1. Hence we write first x minus plus 1 into x minus 1. This is the numerator. X plus minus plus 1 into x minus 1. And divided by denominator is the replace this x by x1. What is x1? 0. Hence write here 0. Also instead of this x we write as a 0. We simplify this right hand side and we get this is equal to 1 minus x square. Similarly, if we check a1x, in a1x if we calculate L1x, then also we want L1 dash of x1. Hence differentiate L1 with respect to x and replace x by x1. Okay, 1 minus x square is the L1x. What is its first order derivative? L1 dash of x is equal to minus 2x. Derivative of 1 is 0 and derivative of x square is the 2x. With this minus sign we get minus 2x. And x1 is equal to, we know, 0. Hence we write as a L1 dash of x1 is equal to L1 dash of 0 is equal to 0. Then to find out the next value L2 of x. Then again subtract all the values of x from variable x except x2. What is x2? X2 is the 1. Then we write x minus plus 1 into x minus 0. Hence we get this is the x minus plus 1 into x minus 0. And then replace this x by x2 in the denominator. Hence here x2 is equal to 1. Hence we write is the 1 plus 1. This is the 1 minus 0. Again simplify this whole term and we get 1 by 2 into x plus 1. Then again differentiate this L2x. After differentiation we can find L2 of x, L2 dash of x is equal to, here multiply x into x square plus x, and its a derivative is 1 by 2 into 2x plus 1. And then put x equal to x2 means x2 is equal to 1, and we get L2 dash of x2 is equal to L2 dash of 1 is equal to 3 by 2. Okay, thus we get L0, L1, L2. L0 dash of x0, L1 dash of x1, L2 dash of x2. Then find out value of x0, a0, a1, at, a2 by putting the values of L0, L1, L2, L0 dash, L1 dash, L2 dash on the right hand side. Hence first we consider a0. A0, what is the formula? 1 minus 2 times L0 dash of x0 is the minus 3 by 2 into we write x minus x0, and we know x0 is equal to minus 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 we get as a plus. Okay, and then into write as a L naught x bracket square. L naught x, what is here? L naught x is the 1 by 2 into x minus x into x minus 1. Hence we write as a, this is x square into x minus 1 bracket square divided by 4. Then by the algebra of equation we can simplify this right hand side, and to find out this a naught x is equal to 1 by 4 into 3 into x raised to 5 minus 2 into x raised to 4 minus 5 into x raised to 3 plus 4x square, and this is the value of a naught x. Similarly, to substitute the value of L1 and L1 dash of x1 in a1x, and we get a1x is equal to 1 minus 2x square plus x raised to 4. Same way, 1 minus 2 times L1 dash of x1, what is 0, into x minus x1, x1 is 0, hence write x1 is 0, into L1x bracket square. What is L1x? L1x is equal to 1 minus x square. Hence we are writing 1 minus x square bracket square. Again simplify this whole right hand side. After the simplification we can write L1x is equal to 1 minus 2x square plus x raised to 4. Similarly, we can find the value of a2x, and a2x is equal to 1 by 4 into minus 3 times x raised to 5 minus 2 times x raised to 4 plus 5 times x raised to 3 plus 4x square. Also, we can consider the formula for b naught x. In b naught x, what is there? X minus x naught into L naught of x bracket square. Here x minus x naught is the x plus 1 into this is the L naught of x bracket square. Again simplify. After the simplification we get b naught x is equal to 1 by 4 into x raised to 5 minus x raised to 4 minus x raised to 3 plus x square. Also, same way we find out b1x. b1x is equal to x raised to 5 minus 2 times x raised to 3 plus x using the formula. And also b2x is equal to x minus x2. x2 is the 1, hence write x minus 1 into L2x bracket square. What is here? L2x. L2x is equal to this 1 by 2 into x plus 1, and its square is a x square into x plus 1 bracket square divided by 2 square is the 4. Again simplify, and to get 1 by 4 into x raised to 5 plus x raised to 4 minus x cube minus x square. Thus, we get a naught, a1, a2. Also, b naught, b1, b2. Then we know the formula for the interpolating polynomial using Hermite's interpolation formula. P5 of x is equal to summation I goes from 0 to 2. Means we can expand this summation. How to expand that? Putting I 0, 1 and 2. And thus we get a naught x of f of x naught plus a1 x of f of x1 plus a2 x of f of x2. And we know this is f of x naught, this is f of x naught, this is f of x1, this is the f of x2. Similarly, in the second term, expand this summation on I is equal to 0 to 2, we get b naught x of f of x naught plus b1 of x into f dash of x1 plus b2x of f dash of x2. And also using this table, we can consider this is f dash of x naught, f dash of x1, and this is the f dash of x2. And then by putting all the values of a naught, a1, a2, b naught, b1, b2, f dash of x naught, f dash of x1, f dash of x2, as well f of x naught, f of x1, f of x2 on the right hand side of equation 1, and we get this equation. Okay, just by expanding. This is the first term, this is the second term, this is the third term. From the first summation we get this 3 term with putting the values of all the parameters. Also, this is the first term of the first summation, this is the second term of the second summation, this is the third term of the second summation. And putting all the values of a naught, a1, a2, b naught, b1, b2, Also, we consider f of x and f dash of xi. And then we simplify this whole right hand side, and you can write ascending powers of x or descending power of x. We get p phi of x is equal to 2 into x raised to 4 minus x square plus x plus 1. And this is the interpolating polynomial for a given data satisfying f of x and f dash of x. Okay, thus we get this is the first f of x. Also, to find out f dash of x, for f dash of x we consider this p phi of x is equal to this equation. Then differentiate this equation with respect to x, and we can find out the f dash of x. This p phi of x is nothing but f of x, approximately f of x, not exact f of x. This polynomial is the approximate to f of x. Also, by putting x is equal to 0.5 and x equal to minus 0.5 in p phi of x, we get p phi of 0.5 is equal to 11 upon 8 and p of minus 0.5 is equal to 3 by 8. Simply putting the values of x in the polynomial and to get the value of p of 0.5 and p of minus 0.5. And this is the required solution for the given problem. Also, for our more better understanding, we take the another problem. Here the problem is given from the following data. Find p phi of x using Hermite's interpolation formula, and hence to get p phi of 0.5. And here given in the first column values of x, in the second column f of x, and in the third column f dash of x. You carefully read the values of x, f of x and f dash of x. Here in the second problem, and if we compare the first problem and second problem, the values of x are same. In the previous problem x0 is given -1, x1 is 0, x2 is 1. Only we are changing f of x and f dash of x. Okay, the question is find out the polynomial, and hence using the polynomial to find out the p phi of 0.5. Okay, here we use the Hermite's interpolation formula, and also you remember one thing: if the values of x are same, if the values of x are given are same, then the values of a0, a1, a2 and b0, b1, b2 will be same, because the values of this a0, a1, a2 is completely based on the values of x0, x1, x2. Also, the values of b0, b1, b2 is depends on values of x0, x1, x2. If you see the right hand side of aix and bix, you can easily understand the values of aix and bix is depends on values of xi, that is x0, x1, x2. Okay, hence you remember, if you find out a0, a1, a2, b0, b1, b2, that will be similar as to example number 1. Hence we don't waste time for a0, a1, a2, because it's just this is the formula for aix. In the aix, what is the 1 minus 2 times li dash of xi into x minus xi. This complete term depends on xi. Also this lix is also depends on the what is lix, just you know the above the formula. Also that depends on the xi, and also this term is depends on lix, means that depends on xi, means aix is completely based on the x0, x1, x2, and similarly bix. Hence we consider the same a0, a1, a2 and b0, b1, b2 in the next problem. Hence then we consider the polynomial p phi of x is equal to 1 by 4 into, then we can expand, then we change only f of x and f dash of x, means this is f of x0, this is f of x1, this is the f of x2, this is the f dash of x0, f dash of x1, f dash of x2. Take all the values from the table and a0, a1, a2 and b0, 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 b1, b2 in the Hermite's interpolation formula, and then we simplify, and to get p phi of x is equal to 1 by 4 into 3 into x raised to 5 minus 3 into x raised to 4 minus 7x raised to 3 plus 7x square plus 4x. And this is the polynomial for the given data. And also the question is given, find out the value of the function at x equal to 0.5. Hence, to put x equal to 0.5 in the upper right hand side and simplify, and we get this p5 of 0.5 is equal to 0.6953125, and this is the required solution. Okay, using these two examples you can easily identify or to find out the interpolating polynomial for a given data. Then we take another problem. Take this is example number 3. Using Hermite's interpolation formula, find interpolating polynomial p5 of x is approximately f of x from the given data below. Also find f of 0.5. Okay, first question is find out the polynomial, and then you find out the function f of x at x equal to 0.5. If you see the table, in the table in the first row the values of x are given. This is x0, this is x1, x2. N is equal to 2. Then this is f of x, the second row. This is f of x0, f of x1, f of x2. Then third row, f dash of x. This is f dash of x0, f dash of x1, f dash of x2. Then by using Hermite's interpolation formula, p5 x is equal to summation of aix into f dash of xi plus summation of bix into f dash of xi. I goes from 0 to 2. Then you just observe the data. Here this f of x is 0. This f of x is 0. This f dash of x0 is 0. F dash of x1 is 0. F dash of x2 is 0. Then we expand this summation on I goes from 0 to 2. Then in the first term, here if you see that this is f of x0, here will be f of x0, this is 0, ultimately that term will be 0, whole term. Also the last term is 0, hence in this expansion last term will be 0 because f of x2 is 0. Hence in this case only find out aix at xi is equal to 1. Because here f of x0 is 0 and this is f of x1 is 0. Hence ultimately this first term in this summation expansion will be 0, last term will be 0, only this summation gives the value of a1x. Hence for this solution find out the only a1x for the first summation. Also in the second, f dash of x, here f dash of x, f dash of x0, f dash of x1, f dash of x2 is 0. Ultimately this second term will be 0 because f dash of x0, this is the first value 0. Ultimately this first term will be 0 in the summation. Second term also will be 0 and third term will be 0. In short, f dash of xi is equal to 0 from I is 0 to 2, and f dash of x is 0 for I is equal to 0 to 2. Hence for the given function or for the given right hand side only find out the a1x. All the remaining values vanishes to 0. Hence we consider a1x. a1x is equal to, by using the formula aix, putting I is equal to 1, we get is equal to 1 minus 2 times L1 dash of x1 into x minus x1 into L1x bracket square. Then find out this L1x. L1x means to subtract all the values of x from variable x except x1. What is here x1? This x1 is 0. This is the x2, this is the x1 and this is the x2. Sorry, this is, here we are taking L1x, that's why here subtract all the values of x except x1. Hence write x minus 0 into x minus 2. Hence x minus 0 into x minus 2. And divided by, replace this x by x1 and we get 1 minus 0 into 1 minus 2. Again simplify numerator and denominator and we get minus x into x minus 2. And then for L1 dash of x, we differentiate this function with respect to x and we get this is equal to 2 minus 2x. And then put x equal to x1 and we get L1 dash of x1 is equal to 0 because here after the simplification x is equal to 1, 2 into 1 is a 2, 2 minus 2 becomes 0. Then by putting the values of otherwise first find out the a1x and then we go for the p5 of x. Here if we consider a1x in this summation we consider a1x equal to 1 minus 2 into L1 dash of x1. This term is 0, hence total second term is 0, hence it becomes as a L1x bracket square. Hence L1x is equal to L1x bracket square and L1x is equal to this minus x into x minus 2. This also can be written as a 2x minus x square and thus we get as a 2x minus x square bracket square. Then putting the value of a1x in the above polynomial and thus we get p5 of x is equal to 2x minus x square bracket square into 4 and this is the required interpolating polynomial for a given data. Also here to find out p5 of 0.5 by putting x equal to 0.5 and we get f of 0.5 is equal to 9 divided by 4 and this is the required solution. Okay, this is in this example here this is the shortcut way. You remember or you check for which values of f of x and f dash of x is 0. If that term is 0 then you skip that corresponding coefficient. Otherwise if you find out that coefficient ultimately at the end the value of that whole complete term corresponding to the values of f of x and f dash of x will be 0. Hence you check where is 0 where is non-zero and as per that you can reduce your time and you get the effective and immediate solution for the given problem. Okay, then we discuss the next question. This is the example number 4. Using Hermite's interpolation formula. Okay, use the Hermite's interpolation formula, find out f of 1.05 means value of x equal to 1.05. Given that f of 1 is equal to 0.84147, f dash of 1 is equal to 0.54030, f of 1.10 is equal to 0.89121 and f dash of 1.10 is equal to 0.45360. Here data is given in different way. Here our question is to find out the value of f of 1.05. If we compare this data with the above table, then we can identify this x0 is equal to 1 and x1 is equal to 1.10 or 1.10. Also here this is f dash of x0 is given, f dash of x0 is given. Also this f of x0 is given, f dash of x1 is given. Hence in this case only two values of x are given. Here first value is the x0 is equal to 1, x1 is equal to 1.1. Hence we get a third degree polynomial because n is equal to 2. Hence 2 into is the only two values, n is equal to we write as a 1. Hence 2 into 1 plus 1 is equal to 3. Hence the degree of the polynomial in this case will be 3. Hence by the or according to the Hermite's interpolation formula, P3 of x is equal to a0 x into f of x0 plus a1 x into f of x1 plus b0 x into f dash of x0 plus b1 x into f dash of x1. Here f of x0, f of x1, f dash of x0, f dash of x1 is given in the table. Only remaining part is to find out a0, a1, b0, b1. Hence we consider L0 and L1. By the same way, here we can find L0 x. L0 x means how many values of x? 1 and 1.1. L naught x means x minus x1 divided by x naught minus x1. L naught x means subtract all the values of x from variable x except x naught. Except x naught means remaining is the x1. Hence we write x minus x1 in the denominator same factor, only change or replace x by x naught, we get this term. Then put values of x naught x1 in this term and simplify, and we get 11 minus 10x. Similarly, to find out L1x. L1x means x minus x naught divided by x1 minus x naught. L1x means subtract all the values of x from variable x except x1. Except x1 means remaining is x naught, hence write as a x minus x naught divided by same denominator, only change x by x1 is equal to, we get 10x minus 10. Thus, using this L0 x and L1 x, we differentiate that and we get L0 dash of x is equal to minus 10, because derivative of this term is the minus 10, derivative of 11 is 0, derivative of x is 1, hence we get this is the minus 10. Also differentiate L1 x and we get L1 dash of x is equal to again 10. And then we can replace x by x0 and this x by x1, and we get L0 dash of x0 is equal to minus 10, remains same. There is no variable on the right hand side. Also L1 dash of x1 is equal to 10. Thus here we get L0, L1, L0 dash of x0, L1 dash of x1. Then to find out the A0 and A1, here A0 is equal to the standard formula. To substitute all the values and simplify, we get this polynomial. Also in A1x we consider the standard polynomial, this is the right hand side. Again substitute the remaining values and simplify. After the simplification we get this is the polynomial. Okay, also in the question we have given find out only f of 1.05. The polynomial is not required at the end. We want only f of 1.05. Hence at the same time we substitute x equal to 1.05 in A0 and A1, and we get A0 of 1.05 is equal to 0.5 and A1 of 1.05 is equal to 0.5. Okay, just for our convenience we are adding this step. Then we consider b naught x. B naught x is equal to x minus x naught into L naught dash x bracket square. After the simplification we get this polynomial. Also here we find b naught at x equal to 1.05, because we want solution at x equal to 1.05. After the simplification we get this is the 0.0125. And similarly we get b1 x equal to x minus 1.1 into 10x minus 10 bracket square, and then to find out b1 of 1.05 is equal to minus 0.0125. Thus we get a0 a1 a2 a0 a1 b0 b1, and then substitute the values of a0 a1 b0 b1, f of x0 f of x1 f dash of x1 f dash of x0, and then simplify the right hand side and we get p3 of 1.05, which is nothing but f of 1.05 is equal to 0.86742375, and this is the required value of the function at x is equal to 1.05. Okay, in this case actually in the given problem the question is given find out the value of f of 1.05. Hence we are putting the value of x is equal to 1.05 in a0 a1 b0 b1. The suppose question is given find out the polynomial, then don't substitute the values of x. Then you keep the function a0 is a function of x, a1 is the function of x, b0 and b1 also a function of x. You substitute in the right hand side of the Hermite's interpolation formula, simplify, and then you get the polynomial. And then after that if you put x equal to 1.05 you get the same solution. Okay, and this is the way for finding the interpolating polynomial and the value of the function at the particular points by using the Hermite's interpolation formula.